forward, then go full screen. 2.3 Changes in matter. Chemical change. A chemical change produces different materials than the ones we started with. A chemical symbol is a one or two letter designation of an element. Compounds are combinations of two or more elements. A chemical formula is an expression that shows the elements in a compound and the relative proportions of those elements. Many elements have symbols that derive from the Latin name for the element. Chemical properties and chemical reactions. A chemical property describes the ability of a substance to undergo a specific chemical change. A chemical reaction is a process that occurs when one or more substances are changed into one or more new substances. Please note that we are not making new atoms or new matter. We are simply rearranging the atoms. Reactants and products. A chemical equation describes a chemical reaction. Reactants are starting materials and are written on the left-hand side of the equation. Products are the end result of the reaction and are written on the right-hand side of the equation. If zinc plus sulfur produces zinc sulfide, then blank is the product and blank are the reactants. Think about it and then I'll give you the answer. So if one atom of zinc plus one atom of sulfur produces one molecule of zinc sulfide, then zinc sulfide is being produced, and therefore it is the product. Zinc and sulfur are combining, so they are the reactants. Recognizing chemical reactions. There are 4 visual clues that indicate that a chemical reaction is likely occurring. A change of color occurs during the reaction. A gas is produced during the reaction. This could appear as steam or smoke or bubbling in the liquid. A solid product called a precipitate is produced in the reaction. So a precipitate would appear as you mix A and B and a solid forms that would eventually settle to the bottom because it doesn't dissolve. If it doesn't dissolve, then it is a precipitate. A transfer of energy occurs as a result of the reaction. This could be exothermic or endothermic. Now we have two videos. So this first one shows the decomposition of mercury 2 oxide and oxygen.
In the classic experiment of Lavoisier, mercury 2 oxide is heated, producing mercury metal and oxygen gas. In the classic experiment of Lavoisier, mercury 2 oxide is heated, producing mercury metal and oxygen gas. In the test tube, we have a sample of red mercury 2 oxide. We will heat the sample and it will decompose to give mercury metal, which will condense at the top of the test tube, and oxygen gas, which we will collect by the displacement of water. The mercury metal we can see as a metallic gray ring in the test tube. We demonstrate that the gas collected is oxygen by testing the gas with a glowing splint. As the glowing splint is brought into the test tube, the combustion accelerates in the oxygen and the splint reignites.
And we have one more video. This is the combustion of manganese. Oops.
In this chapter, we are going to explore the difference between physical properties and chemical properties of substances. If we observe the magnesium metal ribbon that we have, we'll look at some of the physical properties first. We first see that it is a solid at room temperature, that it's a shiny metal, that it conducts electricity. Those are some of its important physical properties. At room temperature, the magnesium does not react very rapidly with the oxygen in the air. If we bring in a little bit of heat, the magnesium rapidly reacts with the oxygen in the air. The reaction is very exothermic, as you can see from the light emitted. The white smoke is actually very finely divided magnesium oxide. What we're left with is the ionic compound, magnesium oxide, which is a white solid. Unlike the flexible metal, the ionic compound is a very brittle white solid. So we've lost the properties of the original metal, and we've created new properties for the ionic compound.
All right, that's the end of the notes. Don't know if you enjoyed this, but hopefully you learned something.